Assalamu alaikum and hi, my name is Dzahierul Aliemy bin Suraini and this is my final year project 1 proposal video presentation. My supervisor is Associate Professor and Senior Dr. Amir Ghani, while my co-supervisor is Associate Professor Technologist Dr. Ramzyzan Ramly. My FYP title is Engine Mapping of FSAE Car Engine. Here are the contents that I will be covering today, which includes project summary, objectives, introduction and background, literature review, problem statement, scope and limitation, methodology, and also lastly, expected results. Project summary. Actually, the purpose of this project is to prepare a new UITM FSAE car to participate in the next local or international FSAE tournament, which stands for Formula Society of Automotive Engineers. I myself, as the final year student, is responsible in the area of the engine for the car. Previously, UITM Shah Alam has participated in the FSAE tournament back in 2016 in Australia. In this project, there are 3 objectives. The first one is to identify input parameters for engine mapping process that can have huge effect on engine's performances. The second one is to determine precise value of those parameters in order to obtain peak value of engine torque and horsepower. The last one is to tune the engine in terms of fuel efficiency as future preparation to enter the next FSAE tournament. Next, we move on to the introduction. Engine mapping is basically modifying the electronic control unit (ECU) of the engine that acts like a brain for the engine in order to modify its behavior. It is widely used in automotive industry, especially in Formula 1, Formula Student, FSAE, and also in modern motorcycles and also regular cars. Now, why engine mapping is important and widely used? It is because engine mapping able to extract the limitations set by the car manufacturers from the factory and allow the performance to be increased in terms of the torque and horsepower. It is also remarkably escalate the fuel economy since the notable low range of rev for the engine speed. And the last one, the obvious reason is because the car is smoother to drive, the obvious result that can be seen after the process of engine mapping, and the engine itself becomes more valuable in the market because of the increase in performances. Next, we go to the literature review. According to A.J. Lawrence, engine mapping is widely known by vehicle manufacturers when associating engine's input parameters with the output, where the input are air fuel ratio (AFR), fuel flow rate (FFR), exhaust gas recycling (EGR), and also engine speed, while for the output are torque and horsepower. There are 2 engine's input parameters need to be observed, which are air fuel ratio (AFR) and also spark ignition timing. Arkawazi stated that the stoichiometric value of AFR is 14.7, which means that the 14.7 kg of air is needed to burn 1 kg of gasoline fuel, while ex-engineer stated that the engines perform best at the value of AFR 12.6, which can be classified as rich mixture. Rich mixture is where the value of AFR is less than the value of stoichiometric value, while lean mixture means that the value is greater than the stoichiometric value. For the ignition timing, it is known that the engines perform best when the spark advance from 17 crankshaft angle CA to 35 CA, and the engine perform best at 31 CA, according to Zari and Kaki. Problem statement. At the moment, the engine at the laboratory of automotive at UITM Shah Alam currently have an issue of failure startup. This is most probably because of it's not fully serviced and it needs to be tuned to achieve the highest possible performance. You can see at the right side is the current situation of the engine. Scope and limitation. For the scope, the project paid a lot of attention in tuning the Kawasaki ER650 engine by manipulating its ECU and its management system. And then the experimental model analysis will be done in a hub dynamometer to observe the growth in terms of torque and horsepower. While for the limitation, the first one is it is very difficult to mimic the real life scenario of racetrack due to the airflow motion are not the same when analyzing using a hub dynamometer. The second one is engine mapping only focuses on the management system rather than the physical aspect of the engine itself, which means the piston in the cylinder of the engine. These are the components involved in this project, which are obviously the Kawasaki AR650 engine itself and the Power Commander 5 injection module, together with the PC5 software, and also the Dynapack 3000 hub dynamometer with its software. In methodology, there are several stages that are being classified from FYP1 until FYP2. FYP1 will be covered from stage 1 until stage 4, while FYP2 will be covering from stage 5 until stage 7, where stage 1 is problem identification and objective recognition. We'll continue with literature review, deciding inputs parameters to be tuned and expected results, prediction, and lastly the engine setup itself, the service and maintenance. And the next one is the engine mapping itself, which the tuning the engine process begin by manipulating the engine's input parameters in the PC5 software. And then experimental model analysis will be done using the hub dynamometer in order to analyze the results for the growth trend of torque and horsepower using the software of Dynapack. Next is the flowchart of the methodology. Firstly, we set up the engine and the dynamometer, and then we continue to set a standard condition for the FRR and also the ignition timing, which is the inputs of the engine. And then we try to run the engine with the constant RPM, constant engine speed, and continue with data documentation and also analyzation. We tune the fuel injection system in order to manipulate the AFR, and if we obtain the value of AFR that we wanted, we continue with adjusting the ignition timing, and then we observe either we got the engine's torque and horsepower that we wanted or not. If we get everything that we wanted, then we can continue to save the engines with complete details. If not, then we have to repeat previous steps. Next, we move on to the expected results. There are 4 subcategories that I will be explaining. The first one is the critical engine's input parameters, continued by air fuel ratio AFR value for top performance, spark ignition timing value for top performance, and lastly expected performance of engine's output. Critical engine's input parameters. The first parameter is the air fuel ratio AFR, which can be modified through a fuel injection system in the PC5 software and tuning device. As I mentioned previously, the lean mixture is where the value of AFR is greater than the stoichiometric value, while the rich mixture is considered to be lower than the stoichiometric value of 14.7. AFR can be observed through a device on the engine, which is the AFR meter. While for the ignition timing, it can be manipulated also through a ignition timing map in the PC5 software and tuning device. It can be controlled by advancing or retarding the crankshaft angle CA relative to the piston top dead center, which means that the piston is at the position of top in the cylinder engine. The results based on adjusting the ignition timing can be observed through the increase in torque and horsepower. Next is the air fuel ratio AFR value for top performance. When the engine is running at the ideal condition, it is known that the AFR is tuned by itself automatically by the previous setting in the ECU of the engine. As the engine speed gradually increases, the air fuel ratio goes from the lean mixture up to rich mixture, which can be targeted at 12.6 as the best performances. Next is the ignition timing value for top performance. It is known previously that the performance of the engine rises from 17-degree crankshaft angle to 35-degree crankshaft angle, and once also said that the best engine's performance happens at 31-degree crankshaft angle. So at the ideal condition, it will go from the lower amount of value up until 35-degree crankshaft angle. It is important to highlight also that every engine have a different value of the best ignition timing value due to several factors such as the engine design itself and the material used inside the element of the piston and the cylinder of the engine. Here are the possible reasons for the engine's failure to start up. The first one could be the failure of oxygen sensor. Next is the spark plug issue or the wiring of those spark plugs, and the third one is the dead battery that needs to be recharged. The fourth one could be the catalytic converter or the exhaust gas valve failure, and last but not least could be the rough or bad installed previously engine mapping setting on the engine. This is quite difficult to figure out which one is the main reason. due to the broken diagnostic device on the engine, which needs to be repaired or finding another new better diagnostic device. The last one is the expected performances of engine output. Based on the requirements set by the FSAE tournament management that require every competitor to install an air restrictor in their engine, it is known that the value of the torque and horsepower will be slightly decreased, but it is still considered as high for the engine to be at 64 Nm torque and also 70 horsepower. And it is quite challenging for every competitor to tune their engine to the best performances with this obstacle of air restrictor. I think that is all from me. I would like to say thank you for listening. If you have any question, please let me know in the contact info given. Thank you.